In the 1980s, there was a need for departmental computing, which coincided with advances in memory, storage, software, LAN, and WAN technologies. Mass-produced microprocessors were suddenly everywhere. Commodity operating systems and competing manufacturers further accelerated innovation in software and hardware. Open networking standards, especially IEEE 802.3 and TCP/IP, and the push to establish global networks began to break down the monolithic, proprietary computing models of the mainframe era. Smaller, cheaper servers could be used to build infrastructure one box at a time. LAN technologies and open standards like TCP/IP made it easier to network standalone servers and provided cheaper, faster scalability. Much like the mainframe, distributed computing came with its own share of advantages and disadvantages. One of the most significant advantages was the low cost, making the barrier to entry very low. This was a dramatic change from the enormous investments required to stand up a mainframe. By design, these systems were also easier to scale, making it much easier to expand an environment to meet growing needs. Most standards were open, and because hardware and software were commoditized, businesses had a wealth of choices when making purchases. Since these were commoditized systems, niche skills were no longer needed to operate and manage them. However, despite the low cost, resource utilization was far from optimal. Underutilization was the norm, which resulted in low return on investment and high total cost of ownership. Despite being scalable, these systems were not highly available, opening businesses to the risks of downtime and data loss. The inherent scalability of the distributed systems also led to sprawl, which made them difficult to secure and manage. Finally, because of the sheer number of components involved in different systems, IT organizations experienced sprawl as well, becoming disjointed and siloed.